Okay, we've talked about volcanoes on Venus. Most of them are what are called shield volcanoes. Shield volcanoes, a lot of people tend to think of volcanoes as being these sort of really tall to a sharp point, and then they spit out all their stuff. The shield volcano, it looks kind of more like a shield of an ancient soldier. They tend to be squatter and lower to the ground, and they are known for having predominantly a lot of liquid lava flows coming from them. And those are the kinds of volcanoes predominantly that we see on the surface of Venus. One of the things that you can see here is a lava flow that's formed uh, from a crack on the surface of the planet. And you can see here the enormous scale of this lava flow. We can see here from here to here is 20 kilometers. So from there to there is 20, 40, maybe this whole lava flow is maybe 60 kilometers long-ish. And, that's really enormous. And one of the reasons why these lava flows can go for such long distances is because the surface of Venus is so hot. It takes a lot of time for this lava to cool and solidify. And so these flows can, be almost like rivers in a certain sense, that they can just flow for very, very long paths. Other volcano-like features on the surface of Venus include lava domes and coronas. Coronas are these sort of oval-shaped features are caused by upwellings of magma underneath the surface. And the lava domes are these sort of circular mound-shaped protrusions that come from an extrusion of viscous lava from the volcano. So it sort of solidifies around it that way. Um, Other surface features of Venus include impact craters. The largest impact crater was named after Margaret Mead, who was a famous anthropologist. But like most of the rocky planets and moons in our solar system, there are some impact crater-like features on the surface as well. Now, here are some of my favorite photographs in our textbook. Um, these are photographs on the surface of Venus. Now, we talked about how you cannot see the surface of Venus from above Venus. You can, possibly see some features by penetrating the atmosphere with radio waves, but really to get fine detailed understanding of the structure, you just can't really see it from above. And so we've actually sent probes to Venus. Actually, it was the former Soviet Union and Russia that sent it, but they actually had probes land on the surface of Venus. Now, because of the horrible conditions that I talked about earlier, the temperature and the pressure, the probe didn't survive for very long, but it lasted long enough to take some measurements and take some pictures and send them back to Earth. And so these are actual pictures of the surface of Venus. And so you can see if I told you this was a picture of somewhere in Hawaii or something like that, you probably would have no reason to disbelieve me. It looks that kind of way. And so the similarities that we see between Venus and the Earth are still rather startling, even though in so many ways they're so very different. Both are rocky planets. They have similar shapes and densities and size. And, the interesting thing is that some people believe that very early in Venus's history, it was very much like early Earth. And the thing is that the two planets which have such similar features, they just evolved incredibly differently. And one of the reasons for that different evolution is the incredible density of Venus's atmosphere. Now, we can see this in this graph, and this is one of those graphs like we've seen before. And I'll just remind you that the blue line here is what's relevant. And this graph is unlike a lot of graphs that you may have seen before in that it has three axes. It has the vertical axis on the left, which you're probably familiar with from your math classes, and that axis is indicating altitude. This temperature axis here is the horizontal axis, and that shows the temperature measured in Kelvin. And then you can see the pressure on the right vertical axis. And so this pressure is in bars. And you can see the surface here is where the altitude would be equal to 0. And if we go to the surface, we see the temperature is about 750 Kelvin. As we talked about, that's almost 900 degrees Fahrenheit. And the pressure is like 90 times the pressure of the Earth. That is incredible amounts of pressure and an incredible density of the atmosphere. And this incredible high temperature is because Venus has been subjected to a runaway greenhouse effect. This is one of the things that we are very scared might happen on Earth. Not that it would ever happen to the extent that it's happened on Venus, but we've talked about how the greenhouse effect on Earth has feedback mechanisms that, for example, on Earth, as the planet warms, the polar ice caps melt, and the polar ice caps reflect sunlight into space. And so as the ice caps melt, less sunlight's being reflected into space, so more of the sunlight's being used to warm up the Earth, which causes more polar ice caps to melt, which makes more light that's not getting reflected into space, which means the Earth warms up. And so these cycles and these loops could eventually spiral out of our control, and we could get such dramatic warming on Earth that it could be absolutely catastrophic. Well, we already have seen a model where that has happened on Venus. The planet has been subjected to this enormous greenhouse effect that's causing these incredibly high temperatures, hotter even than the surface of Mercury. That's how hot the surface of Venus is. And so the reason for that is that the atmosphere is primarily carbon dioxide. Now on Earth, we have been putting carbon dioxide into our atmosphere, and that's caused global warming, that's caused the temperature of the Earth to rise. Well, you can imagine Venus has so much carbon dioxide in its atmosphere that most of the sunlight that hits Venus doesn't actually make it down to the surface. Most of it is reflected by its atmosphere. That's why Venus is the brightest object in the sky next to the moon at night, because most of the sunlight doesn't even make it down to the surface. But the tiny fraction of sunlight that does make it down to the surface is completely trapped, or almost completely trapped, by the atmosphere, which is this incredibly dense greenhouse gas. And so that constant holding in of heat is what has raised the temperature of Venus so dramatically. And so if we look at this graph, we see a few other features. We can, as we follow the blue line, we can see that as you raise in the atmosphere, if you get to, almost 50 kilometers up, you can see that the atmosphere is similar to the atmosphere of the Earth. But, of course, when you get to that point, you're seeing sulfuric acid clouds, and sulfuric acid rain happens up here. It's kind of a inhospitable place no matter where you go, so you can get away from the crushing pressure. If you go up high enough, the temperature's normal, the pressure's normal. Some people have even joked that we might have like hot air balloon cities on the surface of Venus someday, but probably that's not the best idea. In any case, as we continue up, you can see that the temperature falls as you get higher and higher, and of course the pressure falls as well as the atmosphere gets less dense as you get more and more into outer space. Another thing that we can tell is that in the higher atmospheres of Venus, there are incredibly strong winds, but that's in contrast to being down on the surface. The pressure down on the surface is really, really high, but it tends to be relatively calm. Another thing that is prominent about Venus is that there are these sort of vortices or whirlwinds at the poles. They seem to be sustained, and we're not really sure how they formed and how they're structured, but it is a feature of Venus that is, like some other things, it's a bit of a mystery. And this infographic is showing you what I was talking about a moment ago with the runaway greenhouse effect on Venus. So you can compare and contrast this with the Earth. And one of the things that you can note is that the arrows, the size of the arrow, the thickness of the arrow indicates how much energy is in the light. And so you have the incoming sunlight on Earth, which is, relatively thick, and a smaller, skinnier arrow is being reflected from the clouds. And so some of the sunlight gets reflected back into space. Some of the sunlight makes it through the clouds to the surface, and that heats up the surface. Now we know that the Earth is radiating infrared because that's the temperature of the Earth, what that radiation corresponds to. And so the Earth is radiating a lot of the energy it absorbs from the sun back into space, but of course some of that is trapped by the greenhouse gases and reflected back down towards the Earth. That actually causes the Earth, that trapping of heat, that trapping of that thermal infrared radiation, actually warms the surface of the Earth. And you can see part of the infrared is trapped, but part of it does actually make it back into space. Now you can contrast this with the picture on Venus, and we can see the incoming sunlight. You can see that arrow is thicker than the one on the Earth. That's because Venus is closer to the sun than the Earth, so it gets more intense solar radiation. But a huge amount of that solar radiation is reflected into space, and as I mentioned, that's one of the reasons why Venus is so incredibly bright in the night sky. Most of its incoming sunlight is reflected away. And you can see the sunlight that does actually make it through to the surface, it's not that dissimilar to the amount reaching the Earth's surface, but that infrared radiation, most of it is trapped, very little of it makes it into space, and that created this runaway greenhouse effect where the surface of the planet just got hotter and hotter as infrared radiation was absorbed and reabsorbed by the surface. And so that's some of the main features and the main things that we know about the planet Venus. Earth's evil twin, but an interesting planet nonetheless.